Let's do some more review. Here's some examples of, well, this first example is one where there are all base e's. And before I can use even a log or anything else like that, I do need to get it down to just one base per side. So you have to use exponential rules. So first off, we've got e to the x times e to the negative third power because it's in that fraction. This other one, I'm going to multiply the x and the 5, so I have e to the 5x. So I'm still not in the spot I want to be because I have two base e's on one side. So this would be the same thing as e to the x minus 3 equals e to the 5x. At this point, I could go ahead and apply a log on both sides, or I could also just notice they're both base e. But if I were applying a log, I'd do natural log, and that cancels both of those out. So I have x minus 3 equals 5x. I'm going to subtract x from both sides. So negative 3 equals 4x, and then divide both sides by 4. So x equals negative 3/4. Now, when it comes to exponential equations, there's actually no such thing as having an extraneous solution because x can be anything. It's only when the original problem has a log in it that there can be extraneous solutions. So you can check your answer and just double check, but for sure this has to be right. So let's do another one. Now remember, when you have exponential equations, first thing you need to do is isolate. So I'll subtract 11. Did not mean to do that in highlighter, but that's okay, it worked out. So subtract 11 from both sides. 23 minus 11 is 12. Now, if you can get them to be the same base, that's fantastic. But if not, like in this case, 12, I can't make that, well, you can make it 2 to some power, but I don't know the power off the top of my head since it'll be a decimal. So if that's the case, I'm going to end up using a log, and I'll match the base that has the exponent. So I'm going to do log base 2. So 2x minus 3 is equal to log base 2 of 12. And remember, I keep that argument in parentheses just so I don't end up touching it later and accidentally adding something to it. So 2x is equal to log base 2 of 12 plus 3. And then divide everything by 2. So x is equal to log base 2 of 12 plus 3, all that over 2. And that's a really bad 2. That's what that is. But that's your answer. Let's do a few more of those. So once again, here's another prime example of an exponential. There are multiple bases, so I do have to get them to be just one base per side, meaning they should match up somehow. So 4 is the same thing as 2 to the second power, and I'm raising that to the x. And while I'm at it, 8 is the same thing as 2 to the third, so I might as well change that as well. So 2x squared, this would be 2 to the 2x because you multiply those together. That's equal to 2 to the third. So I'm still not ready to go because I still have multiple bases on one side. So I do need to condense this. And the rule is you'll add those together. So it'll be x squared plus 2x. Now I can apply a log to both sides, or I can just, since they're both the same base, you can just get rid of them. But if you apply the inverse log base 2 to both sides, they both go away anyway. So you have x squared plus 2x equals 3, and then we're going to go ahead and solve. So subtract 3. This is a prime example of one where we're going to have to factor. In fact, this factors to x plus 3x minus 1. So our zeros would be negative 3 and positive 1. Once again, since there are no logs in the original problem, I don't have to double check for extraneous solutions. Just a few more to go. Here is a logarithmic equation, but remember a natural log and base e are inverses. So this is actually just the same thing as saying x minus 5 has to equal 11. So I'll add 5 to both sides. So, whoa, I'm messing up my x. So x has to equal 16. And if you plug 16 into that log, you do get a positive answer, so we're good. And let's do one more, just for fun. Here's another log equation. Both logs have x's. This is another one where we're going to have to condense first. Coefficients always need to go in and become the exponent. So this one's a subtraction one, so when we condense, because remember we can only have one log per side, the x squared, so the argument on the first one is going to go on top, but the x plus 1, since that's the log that was subtracted, needs to go on bottom. And then we'll go ahead and apply our inverse, so it's a base of 2 to both sides, since that's what the log's base was. So I have x squared over x plus 1 is equal to 2 cubed, or to 8. Oh, this one's a good one. So multiply both sides by x plus 1, because I don't like denominators. I want to get rid of that fractions. So I'll get rid of that denominator. So x squared is equal to, and I'll distribute 8x plus 8. Now there are multiple terms and it's quadratic, so I'm going to subtract everything and get it equal to 0 and factor. So if you look at this problem, there are actually no factors of 8 that add up, or sorry, factors of negative 8 that add up to negative 8. Meaning the only way to solve this is the quadratic formula. So I'll have x equals positive 8 plus or minus the square root of negative 8 squared minus 4 times our a, so is 1, and b, c is negative 8. There we go. All that's over 2 times a, so 2 times 1. So I have 8 plus or minus the square root, and let's figure out what that square root is. So 8 squared is 64. And we got a minus 4 times negative 8. And so that's a positive 96 over 2. Which I'm almost positive this is going to simplify. So 96 is divisible by 16. So it's the same thing as 16 times 6. And 16 is a square root, so this is 4 square root of 6 over 2. And so all of those are divisible by 2, so we've got 4 plus or minus 2 times the square root of 6. Now let's just see if both of those end up working. Because remember, even though it's got, so I'm going to write them out separate, in fact. 4 minus 2 squared root of 6. So I'm going to check both of these. I'm circling them for now, but that doesn't mean they're actually right. So I just need to make sure that when I plug them in, I get a positive number. So 4 plus 2 times the square root of 6 is approximately 8.9. So that one will work because 8.9 plus 1 is still bigger than 0, and so is 8.9. And let's just double check the other one. Now this one's approximately negative 0.9. So that one does not work. And that's because if you plug it into that first argument is already x, so you'll be getting a negative argument, which is a problem. So this one I just canceled out as extraneous. The first one, however, does work.